Today we're going to look at naming some basic organic compounds. We're just going to look at straight chain and cyclic alkanes. So carbons, if you don't remember anything else, organic compounds have carbon as their basic backbone, and then hydrogens will be connected to the carbons. In these, the carbons will always have 4 bonds, and it has to do with its electron configuration. We're not going to get into all that right now. The simplest organic compounds are composed of only carbons and hydrogens, and those are called hydrocarbons. And we're going to be looking at this first class called alkanes. These are called alkanes because the carbons in this particular molecule have only single bonds between their elements. So your simplest alkane would be a carbon that had 4 bonds, and then off of those 4 bonds you would have 4 hydrogens. Alkenes are different because you're going to have at least 2 carbons, and between those 2 carbons you would have a double bond. So you have at least 1 double bond in that molecule. A double bond, remember, is going to be made up of 2 pairs of electrons, where single bonds have only 1 pair of electrons. And then for alkenes, alkynes, it's going to have at least 1 triple bond. So that means that you would have a total of 6 electrons, or 3 pairs of electrons in that particular molecule. But for now, we're just going to be looking at naming alkanes. So straight chain alkanes, this is your general formula where the N represents your number of carbons. So once you know your number of carbons, then you will be able to figure out how many hydrogens you have by putting in that number for N here and solving. So for example, if we know we have 1 carbon, then if we put in a 1 for our N's, we'd have 2 times 1 plus 2 will give me a total of 4 hydrogens, which is what I showed you earlier when you had the 4 bonds around the carbon and then the 4 hydrogens. You will use prefixes in this case, which will, some of them will be similar to the ones we did with the covalent compounds, but the first 4 are different, and these prefixes indicate the number of carbons that you have in that particular compound. You always have the suffix on this, or the ending will always end in ane, which is part of the term alkane. So let's look at some examples. Now, here are the prefixes that you need to know, and these are some things you need to memorize again for carbon numbers. So 1 is for meth, 2 is for eth, 3 is for prop, 4 is for but, and then these rest of these should look like the ones that we did for the covalent compounds. 5 is pent, 6 is hex, 7 hept, 8 is oct, 9 is non, and 10 is dec. So this will indicate your carbon number. So when we go back and look at our molecule that we did earlier, where we had carbon with 4 hydrogens, then this is going to be called methane, because I have a single carbon, that's the meth, and it's an alkane, that's the ane part. Now if I wanted to draw the formula for ethane, which would be our next one in this list, eth refers to the fact that I'm going to have 2 carbons. So remember, we can use C2H2 times 2 plus 2. That's going to tell me that I'm going to have double plus 2 the number of hydrogens, or 6 total hydrogens on this molecule. If I'm not sure about that, I can always draw this out. So I can say, okay, I got 2 carbons, put a single bond between them, so that represents one carbon on each of the, one bond on each of these carbons. And remember, each carbon can have 4 bonds, so that means that this carbon can have 3 more bonds, this carbon can have 3 more bonds, they each have 4 bonds. Wherever there's not something, that would be where a hydrogen would be. So this would be a hydrogen, 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 hydrogen, hydrogen. Count them up and you're going to get that 6. So see if you can figure out what the molecular formula, these are molecular formulas here because they're not really showing you a structure, they're just telling you the quantity of each element in that compound. And that's basically what we're learning to write, are your molecular formulas. So if I put propane, prop tells me that I have 3 carbons. So how many hydrogens would you have in propane? Well, it's going to be 2 times 3, which would be 6, plus 2, giving me a total of 8. So try that with some of the rest of these and see if you can figure out how to go from the name to the formula. Now, if you're doing this from the formula to the name, then basically all you have to do is look at your carbon number, use the correct prefix, and add the A and E. You just got to make sure that this hydrogen number is double plus 2 the number of carbons. Because if it's exactly double, then that's a different kind of alkane. So here's some examples. If we name these, you have 6. So the prefix for 6 is going to be hex. And since this is twice, which will be 12 plus 2, that'll be 14, this will be hexane. This one we've already done, but that was 3. So 3 times 2 is 6 plus 2, that's 8. So this will be prop for the 3 carbons, and then ane. If I have heptane, if I'm writing the formula out of the name, hept means 7, so I'll have 7 carbons. And then to figure my hydrogens, remember it's going to be twice the number of carbons, so that would be 7 times 2 or 14, plus 2 would give me 16. And then for butane, the but tells me I have 4 carbons. 4 times 2 is 8, plus 2 gives me 10 for my hydrogen number. The other type of alkanes we're going to look at are cyclic alkanes. This means they're in a ring shape. The smallest ring has 3 carbons because you can't really form a ring with 1 carbon or 2 carbons. So here is its general formula. If you'll notice, the hydrogen number is exactly double my carbon number. I'm still going to use the prefixes that I use for my carbon number, but to tell that I have a ring in my name, I have to put a prefix to indicate that it's a ring. So I'm going to put cyclo in front of the carbon name, so that whatever that carbon number is, and then I'll also end it with an A and E ending. So it's really similar. It's just you got to make sure that your hydrogens, if it's exactly double, we know we put cyclo at the beginning. If it's not, if it's double plus 2, we leave off the cyclo. So if we have a 3 carbon ring, the number of hydrogens would be exactly double our carbon. This would be 6. And if I wanted to name that, this would be cyclo to indicate it's in a ring. And then 3 carbons is prop, and then we put the ending ane. So for some practice, so here's some naming rules. The only difference, like I said, is you got to use cyclo for the ring where you don't use it for the straight chains. So let's look at some examples. So you can see here that our hydrogen number is exactly double my carbon number. So I put cyclo at the beginning. My carbon 8 is going to be oct, and then we put ane. Now this time you do need the double O because you can't really say cyclooctane. It doesn't sound right. It'd be cyclooctane. And then here we have 5. 10 is exactly double. That's going to be cyclo. And then 5 is pent. And then we end it with ane. So if I wanted just plain old pentane without the cyclo, I'd still have 5 carbons. The difference is going to be I'm going to have double my hydrogen number, which would be 10 plus 2, giving me 12. So the hydrogen number is what makes these different from one another. If you look at the name and you want to go the opposite direction, then you know that your cyclo tells me I'm going to have double my hydrogen number of my carbon. So I have 4 carbons, that means I should have 8 hydrogens. If I have, and I've got an extra letter here, if I have cyclodecane, then decane tells me I have 10 carbons, so how many hydrogens would I have? Exactly double, which would make it 20.